So today we are looking at analyzing the quadratic model in its inverse. So when we're looking at this first story, the police department offers a special class interested high school students, and it's going into forensic science, which they talk about the skid marks. And we talked about skid marks, and there are a lot of things that go into the skid mark formula, depending on the road condition. If it's a new road with a good rough surface, it's going to have a quicker stop pattern than it is if it is a older road that's smooth. So this is based upon the friction of the surface on that particular road. They have to do some calculations to find the coefficient of friction, which is one of the numbers that are in this. And that's just so that you kind of know the background of this formula. And so we're going to complete a table based upon our function. Oops. And so our function is here. And what you're going to do is we're going to plug in our data to come up with the output. So this is our S and this is our F of S. What do you think S stands for? That is our speed. What do you think the F of S stands for? This is the length in feet to stop. So we're going to plug in, if you're going 25 miles per hour, into this formula, what would your stopping distance be? And so our independent was our speed, and our dependent is the stopping distance. So take a minute and plug those values in. These are the values you should have come up with. As you're increasing in speed, the stopping distance is increasing. According to the table, so again, we're not looking at an equation, we're looking at just the table. What are the domain and range? Well, the domain is just from 25 miles per hour to 110. So this is the only piece of information we have is from that range to that range. And then our range is our smallest range is 18.65 all the way up to 490. So let's think about what that 490 means. So there are 3 feet in every yard, and there are 100 yards in a football field. So when you're going 90 miles per hour, it's going to take you 1 football field to stop on this road surface. And then I want y'all to take these values and I want you to sketch them in the graph. So you should come up with a sketch that looks like this. And if I was actually graph the line to go along with it, it would be going up. And we're looking at, this is a positive one, so that means the parabola is in this shape. And so that means we're looking at the upward swing of this right-hand side. So in one piece of evidence, the skid mark is 300 feet long, 1 football field. Use the graph to analyze and estimate. So 300 would be about what speed? So you should have come up with it being about how long, do you think? I would say somewhere in the neighborhood of just shy. So here's 60. Here's between 60 and 90. That's going to make this at 75. And so that makes this at about roughly 80 miles per hour. And so that skid mark is going to be created by a car that's going roughly between 80 and 85 miles per hour. And y'all could have, oh gosh, approximated that off of the chart. So anywhere in that range, because you can see it's less than the 90, but where it's going to be at exactly, we know it's going to be between these two. And it looks like it's going to be closer to the 90 than the 75. So we're going to determine the exact speed of the car. And how you can find the exact speed of the car, I'm going to go ahead and do over here on the side. So we want to use our formula, which was 0.034 times x squared plus 96 hundredths x minus 26.6. But we know the stopping distance, so we know the 300 is what it's equal to. So now I need to solve this to get the x squared by itself, or to get it solved to where we can find out what x is. So that means that we need to use a quadratic formula because I can't get the x by itself. And so that gives me 0 is equal to 0.034 x squared plus 0.96 x minus 326.6. And so I'm going to plug it into the b squared minus 4ac first. So that's 96 hundredths squared minus 4 times 34 thousandths times 300 and negative 326.6. And when I find that number, by typing all that in my calculator, I get 45 point roughly 3392. And so I'm going to use that information, I'm going to plug it into the quadratic formula. And remember, the quadratic formula was x equals negative b plus or minus the square root of my discriminant, which is what we just found, divided by 2a. So negative b means it's negative 96 hundredths plus or minus the square root of 45.3392 divided by 2 times a, which was at 34 thousandths. And so I'm going to use my graphing calculator. I'm going to go ahead and type that all into my home screen. And what I'm going to do is I'm going to do the positive and then separately do the negative. And so when I do the positive, I end up with 84.9035. Now, thinking back to how my graph looked, this graph was going up, remember, and if I was to continue it on over here, it would look like this. I don't need that negative number. I'm only concerned with that positive. And so now that I've gotten a positive answer, this is a speed my car was traveling in order to create the skid marks, or that stopping distance at 300 feet. Now, we want to take and see, because it's people are not going to want to take and do the quadratic formula. We'd rather have an equation that's solved to where all I have to do is plug in the 300 and come up with an output. And so we want to do an inverse. I'm not going to make you create the inverse right now, but let's talk about what the inverse would be. The inverse means that my new independent value, which is our input, would need to be the stopping distance. Which would give us the output, or our dependent value, which is our speed. And that means that my domain is now my stopping distance, which was that 18.65 through to that 490.4. And my range is my speed, so that 25 miles per hour through 110. So would this equation always hold true for any speed? Well, obviously we can't plug it in negative speed because we can't go in negative miles per hour. But can we go a certain speed where this is not going to work? Well, if you get too fast, then it's going to affect your ability of your brakes to work, as you may have brake failure. It's going to affect the ability of the friction of the tire because you're going to wear it down. So there is more to it as you go at faster speeds. So I want you to predict, just using this data that we have, I want you to make a graph where the plug-in value is your stopping and this is your speed. And that means we're going to do the inverse of this page. And so that means it's going to be kind of flattening out and going this way. It's not going to keep curving up. This will become our new x and this will become our new y for the inverse. Go ahead and graph that. It should have given you a graph similar to this. And so when we're graphing it and we're wanting to make some estimations, we can use our graph to help us come up with a good estimate. So I want you to take that graph and I want you to look and see and make predictions of what do you think it's going to be at 50 feet stopping distance. How fast was I going? How fast do you think I was going at 175? If it took me 175 feet to have that stopping length, that stopping skid mark length, and that 350. And so that means that I'm going to be looking at 50, which would be right here, and trying to figure out what that number is. And so I put that at 35 miles per hour. At 75 feet, I said that was about 65 miles per hour when I made my estimation. And at 350 feet, that's about 90 miles per hour. A little bit more, but it's just about. So on the next question, it asks us to write a report and discuss possible factors that have the length of the skid marks of the vehicle. So you're going to see what could affect this stopping distance. Well, obviously the speed of the car will affect the skid mark. So that's what we've proven with the formula. But there are other such factors that will affect it, like how good is the road? Is it a good rough road that's going to stop you, or has it got a slick surface? Is it loose gravel? Is it a smooth surface? Is there ice on the road? Is it just recently rained? Is there a puddle you're going through? The weather that's going on out there. Is it hot? Is it cold? The grade of the road. So what that means is, if you think about it, if you're going up a hill, you should be able to stop faster than if you're going down a hill. Your vehicle type, how heavy is your car? Was it designed for? And so each of these will affect that stopping distance formula, and they have to consider all of those features when they're trying to calculate how fast you are going. For homework, you are going to be doing the page that's talking about living to 100. You're going to make those predictions. You're going to use your graphing calculator to run the regression model. And then come back with that page done tomorrow.